The next big thing where geology really plays an important role in our everyday life are things that we take out of the ground. And these things have to be mined. So whether it is the cement for buildings or bricks or even clay that you put onto magazine covers to make them shiny, metals, gold, silver, jewels, they all come out of the ground, and a geologist has to find where they are before you can start digging to get them. If you don't know where they are, you're going to do an awful lot of digging, which is very expensive and time-consuming, to find things that you could find much easier if you knew where they were. What we're going to start off with today is we're going to take a look at where iron comes from. Okay? We're going to start with iron, and we're also going to do another one on coal. Okay, and both of these can be used together to make the steel that we use for everything, whether it's in cars or trucks or airplanes or the girders for buildings. The steel is a big thing that we use in everyday life. So the first thing we can do is we can start off with a rock that contains a bunch of minerals in it, including the mineral magnetite. And the mineral magnetite is an iron oxide that is magnetic. Thus its name. And so therefore you can find it with using a magnet. Okay? Otherwise, and that is what we call the ore. Okay? And the ore mineral is what we want. Okay? In addition to that, surrounding those ore minerals are what we call gangue minerals. And gangue minerals are minerals that we don't want. Okay? And those will make up the majority of the waste rock. So what we want to do is we want to separate the ore from the gangue minerals. And the proportion of ore we have to gangue minerals is going to tell us whether something is worth mining or not worth mining. And that process is what is called an assay. So when you assay an ore or assay your rock, you figure out how much ore there is relative to the total rock in a percentage, and that tells you whether it's economic to mine it or not. So the first thing they do in these mining operations is to crush the rocks up. So you put it through a big crusher and it breaks the rock up into a bunch of pieces. Okay? And those pieces then we can separate into our ore and our gangue minerals. So the starting point we'll do is we will weigh some sample on our scale, and here's our unknown amount. Then what we'll do is we'll take that unknown and we'll put it on a tray. And on this tray, what we're going to do is do what is called a magnetic separation. And this is what they do when they use magnetite. You find a very strong magnet, and how we're going to do that is we're going to separate out the magnet by putting in the magnet in a piece of plastic. And we're going to run the magnet over our sample, and we will see that all the magnetite in the sample will stick to the magnet. Okay? And then what we do is once we get the magnetite out, we can then re-weigh the sample and see how much magnetite we have relative to the waste rock. And so in this one, you see there's a very small amount of magnetite compared to sample that I put out. And so this is probably not an economic deposit. We wouldn't want to use it. But what we do is we take the amount we started off with, our weight that we began with, and we compare that to the weight of the ore that we have. We work out a percentage, and then that is how we assay the material. This is called magnetic separation, and that is how you separate out magnetite from your ore. Another thing we can do is what is called a heavy liquid separation. Now this is another very common way that you separate ore from the assay. Once again, you crush up your material and you would then have a mix of ore and assay. Now what we're going to do in this case is we are going to look for coal. Okay, so we're going to look for coal, and the coal is what you would use in the smelter to turn that magnetite into iron. So what we do with the coal then is we take a sample of this and dump it into our container, and so we have a certain measured amount in our graduated cylinder of mixed material. Okay, so after we then dump our mixed sample into the water, into our heavy liquids, then we can separate the two of them out. So what will happen is the lighter stuff floats to the top, the heavier stuff goes to the bottom. Now what we do is we take a screen and we can get rid of the lighter stuff off of the top. So all we have to do is scoop it, and all of that vermiculite comes off to the top and sticks to the screen. And what will be left at the bottom of this, after we scoop out all the vermiculite, is a sample of anthracite. So once we dump this out into a material, we will get pure anthracite, otherwise known as coal, and that is what we would use as our fuel. Now, a lot of our power plants around here, in fact, most of the electricity you use, comes from the burning of coal. And in the East Coast, most of our coal is anthracite. In the West, it's a different type of coal. But we use anthracite here for generating electricity, but we also use it for fueling furnaces to smelt some of our iron ore. So in fact, you can take both what you got from the one part of the exercise as the fuel, as well as the magnetite from the other part of the exercise, and you heat the magnetite up using this fuel, put in what is called a flux, usually limestone, and what you will get as a byproduct will be pure iron that you can then use to build your materials out of as girders or whatever, and also what is called slag. And slag is the leftover material. So you can kind of think about how much effort it takes to mine iron out of the ground, to mine your fuel in order to turn that iron, that magnetite, that ore into iron, and then how much slag you have as leftover material. And you will see there is quite a lot of waste when it comes from going from our ore in the ground to our finished products. And so therefore, if we look at that, we can start seeing why there's such an argument for recycling, because you cut out all of the separation part, all of the waste rock, and all you do is reheat it and turn it back into a new product. So that is what you will do today in your mining exercise. You will assay two parts, one by weight, one by mass, and that's the magnetite. The other part you will do using a graduated cylinder, so you're going to assay by volume, okay? And so it's a volume and a mass assaying, and you will fill out the sheets that have been handed.